Hello, everybody. As already mentioned, I'm Aimo Kõva. I come from a company called Datel. A little bit about our history. We're almost 35 years old now, and we specialize in geoinformation systems. Now, today, I'm going to talk a little bit about geoinformation systems themselves. OK, I have a technical issue. And then I'm going to explain what we are doing with the satellite data that we are gathering. So, we come from a background of land management systems. We were the ones who developed the Estonian mapping system, also the e-cadastre system, the previous version of Estonian tax administration tools, and also the building registry. Now we are in a state where Estonian building registry has a digital twin, which uses the data from the building registry itself. And also, as you can see, you can insert your BIM models into the application as well. And in the future, it's going to be in a way that you can basically walk into your BIM model virtually and see what you have planned in the city and see the cityscape right in front of you. Now, this is our background. Now, I want to talk a little bit what we are doing internationally. This is an example from Central African Republic. It's an interesting country to be in, but this project came from Ivory Coast, and from Ivory Coast private sector, actually. They wanted to gift this application to Central African Republic. And what we did, we gathered all what I was talking before, added satellite imagery as well, and we started their e-cadastre from scratch. Because right now, they don't even have any digital data. They only have paper-based data. And also, they don't even know where all the buildings are. So what we did here, we took our core system from Estonia. We added a different system or a layer of different system called the tax administration area. And now this application can do taxation as well. It's a really simple thing, and it calculates the tax based on square meters, basically only. Now, with satellite imagery, they didn't have a good base map. So we ordered a good resolution satellite imagery from Neo, Airbus, and we built them a base map as well. Now, after that, it turned out that they don't know where their buildings are. So we used Microsoft AI, our own AI tools, to detect all the buildings from them as well. So now, they can just go in and start building their e-cadastre system and building registry in one and the same system, and also do their taxation from there. It's a pilot project. There is a lot of interest in it, and it's a good tool to start from somewhere and also to avoid corruption. It has an addressing system as well, because they didn't have that. Now, I promised that I will talk to you about what we are doing with satellite data. The picture you see here is Algete, Spain. They have an interesting real estate tax issue. Mainly, the real estate tax is quite high. It is over 50% of the local government's revenue. So people sometimes forget to declare all the buildings they have. Now, we compare the satellite imagery against their building registry and their tax registry. So with that, we are detecting the pools, the misregistered buildings, and we can let the local government know where they are. I know we might not be the most popular company because of that, but it's a really good tool for the local municipality to get things in order. Well, I have the same examples from Estonia as well. There are 2 municipalities already using, but they are not using it because of the taxation reasons. They are using it because of safety. And we are monitoring all the restricted areas there. More about satellites. There are other satellites in orbit that can do a lot of things. This is an example from Poland. And what we are doing here is we are using INSAR satellites. These are basically radar satellites. And we detect deformation monitoring from satellite in millimetric scale. So the example you see here is actually quite famous one. The color code is red is subsidation or things moving down, green is stable. So the red area is the railway station. But it was built on a closed mine, underground mine. So you can see from the graph here that the area was quite stable. And afterwards, you can see that it collapsed in 3 stages. And this could have been avoided when you would pump in water and make the ground a little bit more firm. The good thing about the satellite data is that the satellites have been orbiting for quite some time already. In this case, the satellites have been orbiting since 2016, and they've been continuously recording. So you can build trend lines, and you can build the triggers to let people know ahead of time when something is going to happen. This tool is also used by local municipalities, but also insurance companies who are interested of the well-being of their portfolio. This application can be used to monitor hydroelectric dams, mining areas, and so on. Now, I will come back to this application for a little more time. Here I was talking about buildings, but it is not only buildings. You also have digital registries about forestry and mining, for example. With this application, or with these tools, you can also detect illegal forestation, or illegal forestry, sorry, and illegal mining, which are very huge issues around the world. So, like always, I am very quick with everything I talk about, so